Hey everybody, I'm Paul Clark. I'm a plant specialist here at Shaw Cable, and I'm working today with...
Hi, I'm Jason Boyachko. How do you do?
We're looking at some PNM stuff. So here at Shaw, we have a proactive network maintenance program that we like to go out and try to fix up some cable, preferably before customers are calling in. So today, what we're going to demonstrate is we're going to use our program and we're going to find an issue and go out and see what we can find out and show you guys what we find, how we do things, and hopefully that helps. So we'll talk to you in a little bit here. Hey guys, so we're gonna take a look at this here on the map. You can see that we have a bunch of red pins all over the place here, and all seems to be coming from one general area, from perhaps an affected trunk. Looking into the different data and trying to dive into, what might be causing some, potential customer problems, as well as hopefully preventing some problems from people calling in. Looking at some of the data, we can see that looking in the OFDM spectrum here, it looks like we have a bit of a standing wave. You can see it in the MER up here. It's kind of bouncing up and down. The ICFR, so the map was showing all the red pins. The ICFR was in pretty bad shape for this one particular channel. It's 47 megahertz. So those are going to be some of the key things that we're going to be looking at is in the upstream 47 megahertz. And then we're going to take a look at the OFDM at the higher end of the spectrum, see if we can figure out where the standing wave is coming from and see what we can resolve. So we'll see you out in the field. So here we are, of course, direct buried underground. What could possibly ever go wrong here? Don't know. So this is where we're starting. We're going to crack open this trunk amplifier and take a look and see what we see on the meter. All right, we're back again. So we've done some analysis here. Our forward issue seems to be coming prior to here, so we're probably going to go and take a look at that in a bit. But the primary reason that we came here was for the upstream ICFR issue on 47 megahertz. So looking at this trunk amplifier, you can take a look at some of the screenshots that we'll include here. But the input was nice and flat on the ICFR. We went to the trunk out, and on the trunk out, we could clearly see the ICFR is really, it's really out of whack here. So we're going to try changing out the trunk board next, see how that impacts everything, and hopefully we'll clean everything up in regards to the upstream ICFR issue. One of the cool things to note about that is using our software analysis, we were able to pinpoint exactly where to go. So we've came straight here first, and we identified that the problem is exactly right here. So not having to go from trunk to trunk or node out or any of that sort of thing, just straight to where the problem is. So we'll see how it goes after this. All right, so we did our analysis. We ended up swapping the trunk board. We found the problem ended up staying, so we ended up swapping out the return EQ. That seemed to clean things up. There's one important thing to keep in mind when we're chasing these types of things. There's some of these nodes, like with direct buried cable and older lines and that sort of thing, there's a lot of different things going on, so trying to isolate what exactly is causing your issue or whatnot can always lead you a bit astray. So in this example here today, we've resolved the 47 meg issue, but there still is a 16 meg issue that's also on the node. So something for us to look at some point here in the future. So that kind of gives us a bit of a close here on the 47 megahertz for this particular example, and we'll have a little bit of assessment and we'll have a little chat with Brady here.
Thanks, Paul and Jason. That was a great job at troubleshooting one of multiple issues in a troublesome node. I know that you have more work troubleshooting ahead of you before you resolve all the issues in a node, but in the end, subscribers will appreciate your hard work. For everyone watching, the backstory to this is that Paul and Jason picked a fiber node using proactive network maintenance, or PNM software. The node they picked exhibited upstream and downstream issues. It was a target-rich environment, but gave them the opportunity to fix multiple issues at the same time. As we saw, PNM directed them to the exact location of the impairment. In this case, they found a faulty return path equalizer, which impacted only one upstream SC-QAM channel. It should not be surprising to anyone who's worked in cable that in an aging cable plant, more than one impairment will often be present. Patience, divide and conquer techniques, and experience are your friends when resolving complex problems. This illustrated just a couple hours work in the typical day for cable operators performing proactive repairs to improve the quality of experience for their subscribers before their subscribers are significantly impacted, or worse, their subscribers' cable modems go completely offline. Good work to the team at Shaw, and thanks for everyone watching. So long.